So as we look, we see there is a good match. And what we're going to do is we're just going to drag this column over to the right, and it's going to bring in all of the variables and the values that match with our lookup key on the student ID. So it was that easy to bring it all in together. There's no guesswork about position of variables, and we've used automation where possible to reduce the potential for error. So that was it for integrating our data sets using Excel. Now we can move on to transforming variables to derive new information. So when it comes to data transformation, the goal can be either to transform your records or to transform your variables. If you're catching on, there's always a pattern to this. We're either talking about variables or records. So the first we're going to talk about is transforming records, which is aggregating. With aggregating, what we're normally doing is summarizing our records. So we're looking to take multiple records and combine them to derive new information. So methods of this include things like taking the sample average, where you maybe have a number of samples on an assay tray and you're going to average them together to remove any issues with machine variance. Normalizing tests. So in this case, if you have multiple tests that have different numbers of records, then you can aggregate those tests and then compare with variance and means to see if you have a difference between two tests. So that's a great way of normalizing your data when you have different numbers of measurements. And then finally, creating benchmarks. So if you have a global average, global mean, or some kind of crosstab, then you can use that to evaluate your variables to say it's above or below the mean or in a quartile, etc. So that's what we're talking about when it comes to aggregating records. When we're deriving, we're generating new variables by processing record values to create either measures or descriptions, more information that can be used to evaluate your data set. So the methods that are included there are converting units, such as pounds into kilograms, which we'll do together, calculating measures, such as calculating the BMI, which normalizes for a person's height and weight in terms of understanding their healthiness. We also have classifying records, which in this case it may be, someone is above or below an average would be a classification, or it could be in terms of quartiles, or it could be in terms of good or bad data. All those are classifying records. We also can match descriptions, and this is a great way to identify if your record is relevant to a certain search. And so we could be looking for either gene matches when we're doing RNA sequencing, or we could be looking for something at a higher level, such as a certain treatment that's being performed on different patients. And then lastly, we also want to talk about deriving intervals of time. So it could be that we're looking at the time between infection when it comes to clinical visits. We may be looking at the duration of treatment. We may also be looking at survival time in the lab when it comes to different tests that we run. So based upon that, we now understand aggregating and deriving variables. We can move on to discussing some simple examples about how this works. So here's a quick example. We've got on the top, we are going to do some converting of units. So here we have students 1 through 10, and we have their height and their weight, and we want to convert the height and the weight from currently in inches and pounds into meters and kilograms, into metric units. And this is a simple conversion of the data set. So you see here on the right, we're going to take our height and convert it into meters, and our weight in pounds and convert it into kilograms. And while this isn't a complex example, it is indicative of the kind of processing that you would normally do for deriving your records. Now, let's talk about aggregating. Take a look at the table on the left, and here you see that we have the full data set for all 20 students, where we have their HIV positivity, their gender, and their BMI. And if we aggregate this data, we can now observe, based upon these two factors, HIV positivity and gender, what the average BMI is for those groups at an observational level. Now that we understand aggregation, let's move over and we can jump into Rocketfish and show you how to do that there. So here we are. We're on the same data set that we were working on before, the combined site data set. And my first step is going to be to convert the height from inches into meters. So I'm going to click on Derive Variable, and we're going to call this height underscore m, and then I'm going to just type h, and immediately you see I've got a couple of options in terms of variables. I'll hit enter to select height. This is something that's nice about Rocketfish. It gives you an autocomplete feature. Then I'm going to type times 2.54 to go from inches into centimeters, and then divide by 100 to go into meters. And as you see over here on the right, I've got my calculations already pre-populated in a preview. Now, I don't really like the fact that I have so many decimals, so to make this a little easier to read, I'm going to go ahead and wrap this function with a round function. So I'm going to say round, and I'll hit enter. And then on the other side of this equation, I'm going to say let's go ahead and round it to 2 decimal places. And once complete, you'll see that the column updates, and you can now see how the height in meters is rounded to the nearest hundredth. So with that done, I can hit derive variable, and the history bar blinks to tell me that the information has been captured. So for all of our records, we now have our calculation of height in meters. So let's do that same thing, but in this time we're going to do it for the weight in kilograms. Now remember, we flagged the weight in kilograms using this unit error. So what we're going to do is we're going to type if, and then we're going to say the the unit error is equal to 1. Then we're not going to do anything. We're just going to take the weight as it is. And if not, we're going to take the weight and we're going to multiply it by 0.45 to convert from pounds into kilograms. So with that done, we can go ahead and preview, and we see we have an error. So we'll go ahead and identify, okay, where's the error occurring? It's actually the fact that we didn't use 2 equal signs. Now that we did, we see that the calculations are done. So you need to use 2 equal signs to test for a logical if something is equal to another. So we're going to hit confirm derived variable mapping, and now on the right we have our weight in kilograms. So that was easy. We now have derived our 2 variables. Let's go ahead and calculate the BMI, which will be the final calculation. We'll type in BMI. We'll then take the weight. In this case, we're going to take the weight in kilograms, and we're going to divide that by the height in meters squared, and we'll just multiply that by itself. And so with that complete, we can scroll over to the right and we see that the BMI has been fully populated. So we'll go ahead and derive the variable, and we're good to go. It was that easy to calculate 3 new variables and derive them in Rocketfish. Now we're going to aggregate our records. So to do that, we're going to click on the aggregate button in the action toolbar. And again, we're going to get our grand mean. We'll go ahead and deselect that, and we'll just select the gender to group by, as well as we will select the HIV positivity. And so here you can see that we've got a crosstab up, and we have an issue because the gender is actually not normalized yet. So we'll back that out real quick, and we'll convert this, all the boys to be male, and that replaces all the values there, and all the girls to be female. And that's fixed. So now we can move forward. We'll do the aggregation step again. Unselect the variables, and then we'll select gender, and we'll select HIV positivity. So now we have 4 options: male, female, yes, and no in terms of being HIV positive. So the next step we're going to do is we're going to select BMI to include as an aggregated variable. And we're going to take the mean, and we'll go ahead and add in the count and the standard deviation. And this will give us our full data set that we need to understand, okay, we've got the mean, but how important is that mean and how representative is it, so we can have all the information we need. And with that, we've just finished deriving, aggregating our records, so we have a new data set that we can use for performing a test on these groups. So is that easy inside of Rocketfish? Let's go ahead now and switch over to Excel. So going back to Excel, we've got the data set that we've been working on, the combined clinical data, and we're now going to calculate the new variables. So first we'll start with the height in meters, and we'll make that equal to the height times 2.54 divided by 100, and we can then take that and we can paste it down so that now we've calculated the height for all the variables, for all the records. And at this point, we're able to move forward. So this is something Excel does very well. We're also going to calculate the weight in kilograms. And the same thing, we're going to do an if statement. And we're going to say if the weight, the unit error, let's go ahead and find that there. Here we go. If the unit error is equal to 1, then we're going to just go ahead and take the weight. So I'm selecting the weight column for this record, And then if not, we're going to take the weight and multiply it times 0.45. And so I'll go ahead and hit enter, and you'll see that I made a mistake because you only need one equal sign in Excel in order to do an equivalency. But Excel fixed that for me. And then I'm going to copy paste here to the bottom. And once I do, I can see that we now have the weight in kilograms for all of our records. And to do a quick test, we can take a look at one of our students which had a unit error in terms of the measurement for the weight in kilograms. So if we check, we can see that this student's weight was 58, and now it's come through as 58 again, which is what we expected. Now let's calculate the BMI. So for the BMI, we'll take the weight divided by the height times the height in terms of kilograms over meters squared. We'll hit enter, and again, copy and paste that all the way down. So it's pretty easy. We've been able to do all of our calculations and derivations here. If you want to see your data a little better, highlight the columns and then double click on the right side to give yourself a full view of your data set. So now let's move on to do some aggregation. We're going to select all of our data, and just like before, we're going to click Insert, select Pivot Table, and just hit OK. And we're going to get a new pivot table, and this one we're going to rename as being Pivot Combined Clinical Data. And with that done, we can now select the gender variable as one of our rows and the HIV positivity as one of our rows. And again, we have this issue where we forgot to normalize the data. So let's go back to our clinical data set, and we'll go to gender. We'll highlight all the data there, and we'll type in for all the boys, let's replace that with M. We'll hit replace all. Okay, made 5 replacements. And then for girls, we'll replace that with F. And now we've made those replacements as well. Okay, so we just updated our data. Now we need to update our pivot table. So the way to do that is to go to pivot table, which has its own ribbon, and then just click on refresh, and there you go. Your data's been updated. Now this view that that you get from using the pivot table is not always easy to turn into a new data set. So what we're going to do is we're going to right click on the header, select pivot table options, and then go to display and click classic pivot table layout. So that's a really important step if you're going to be developing data sets that are aggregated inside of Excel. We'll also right click at the header and remove the subtotal. And then finally, let's bring in our BMI calculation. So we'll go to the very bottom of this list, select BMI, put it in the values, and we'll go ahead and change that to average. So now we've got the averages. We'll pull in the BMI again, and we'll change that to count. And then we'll pull in the BMI one more time. Again, you have to pull it in every time and change it every time in Excel. And we'll go ahead and we'll select on the drop down here on the list a standard deviation. Okay, so now we've got our data set. It's been aggregated for us and we're ready to go. And you can see here that the standard deviation wasn't calculated because in Excel it's a sample standard deviation. So that was it for transforming your data. Now we're ready to take on the last step, which is extracting data from your transformed data sets. Okay, so now let's continue with extraction, the last step in data preparation. So the two types of extraction you can do is, once again, based on variables or records. So the first one we'll talk about is the variable side, dimension reduction. Here you're going to screen your variables in terms of which of those variables are actually going to be useful for you in analysis. The first step you can take is to simply identify which of your variables are going to be relevant. This can be based upon the test that you want to perform and the knowledge of which variables are likely to be relevant in your analysis. It's the simplest and most straightforward way of reducing the variables that you're going to use. The next is missing values. If you have a variable that has a number of missing values in it, it's probably not going to be all that important to your analysis. So oftentimes that's the basis for removing a variable as well. Another is based on correlation. So especially if you're doing any type of regression analysis, correlation between your indicator variable and any of the predictor variables you plan on using can be a basis for excluding it. And the best way to do this is either with scatter charts or by using a correlation matrix. And I actually have provided you with a formula you can use in Excel to calculate the correlation between two variables. Finally, progressive elimination is another tactic. And in this, you would start by using a large set of variables that you want to test. And then based upon which of those variables are least relevant, usually using some kind of regression method, you would begin to cut down the number of variables until you have the smallest but most powerful set of predicting variables for whatever you're measuring as an outcome. So that's the first type of extraction you can perform. And this is a really good example of how your analysis results can work back into your data prep to help you refine your data sets until you get the data set that works best for what you're studying. Then when it comes to records, we're usually talking about subsetting. And subsetting means sampling your records in either a direct way or an indirect way. So a direct way of subsetting your records may be based upon a condition. So you may subset all the records that are male or female, or you may be subsetting all the records that are of a good quality. That kind of conditional subsetting is the most common. The next is called record splitting. And record splitting is where you literally want to divvy up your data sets because you plan on analyzing them separately. And this is going to be, instead of based upon some condition, it may be based upon simply a count. And you may have different groups that are analyzing different subsets. Another approach is random sampling. This is oftentimes used whenever you want to treat your original data set as a population, and then you want to see if any random sampling of that will allow you to increase the efficiency of your analysis. And finally, stratified sampling is where you have a direct pattern you want to use to sample your data set to simulate tests in the real world. Again, kind of using your original data set as a population. So in terms of the most basic types of extraction methods, we'll start at the very top here with splitting your records. An easy way to split records is just to use a filter, and this is probably the number one way that you're going to see record subsetting occur. You can split your data set based upon, say, the gender variable, where we're going to separate all the boys from the girls by separating based upon whether or not the gender is equal to M or F. And so that's simple. You can see it here at the top. You start with one data set, you split into two. In another example, we may only want to study the interaction between gender, BMI, and HIV positivity, which has been our example so far. So in order to do that, you may simply want to eliminate all the other variables. And a way you can do that is by hiding your variables in Rocketfish, or simply by only selecting, in a kind of positive manner, those variables you want to keep in Excel. And we'll show you how to do that in our example. So let's go ahead and switch over to Rocketfish. And what we're going to do is we're going to back out to the dataset version previous to our aggregation step. Just as a note, you can always roll back your dataset in Rocketfish, which is a pretty cool feature because that means you can go all the way back to the very beginning and see your dataset as it originally was. And then you can roll forward and you can see your dataset come together in real time, which is really exciting, especially if you're ever working with someone else and you want to understand what kind of work they've been doing on their data. So now that we have backed out our data set to the point that we want, which is before the aggregation, we can start by going to the gender variable, selecting the filter, and then saying, if this text contains the letter M, then we're going to select those variables. And here you can see that we've selected all the males. So what we can do is we can say, okay, let's go ahead and we're going to create a copy of this data set. So we just duplicated it. And we're going to rename this boys only data set. A little exclusive, but that's okay. So we're going to open this up. And now what we're going to do is we're going to take the filter of the gender, and we're going to say text does not contain M. And now we have the girl data set, so we can rename this. We'll rename this data set girls only data set. I'm going to go back to my data sets, and this one just has the boys, and we can rename this boys only data set. So this will remain true as long as the filter is on. If we want to, we can even delete the records in a repeatable way. So let's go ahead and do a negative filter. We'll say text does not contain M, and now we switched over to the girls. We can then select all the records for the girls in this data set, and then come over to the right and select delete. And so now we just got rid of all the records that were girls, and if we clear our filter, we'll see that we only have the boys left in our data set, so 11 records for boys. Now if we go back to the girls only data set, again, this is only persisting with the filter. If we go ahead and say text does not contain, or text contains M, we'll select that group. So we're selecting all the boys here. And then we're going to go ahead and hit delete record. And now we only have the girls in this data set. And what's great about this is that it's fully traceable back to our original data set. And you can see here that we deleted all the records that had boys in them. So that was easy for subsetting our records. Now let's talk about eliminating our variables. If we want to, we can do it in two ways. First, we can select our variable that we don't want to keep. So in this case, we'll select age, and we can just delete the variable. And that literally removes the variable from the data set. And you can see here that the variable age was deleted. And so that's pretty easy. Another way that we can eliminate variables is we can hide our variables. And this way the variables will stay available to us later in the future, but if you export with filters, you will no longer see these variables. So we're just going to go ahead and hide. And what's great about this is that with hiding you can always bring them back if you want to. So also get rid of the blood type, and now we have a small data set of just the girls and their HIV positivity and their BMI. And if we go ahead and hit export with filters, then we can put this data set, we'll put in the downloads folder, and this is called the girls only data set, and we'll give it even a more descriptive name. We'll call this gender, BMI, HIV pos. And if we bring that data set back in, go ahead and add in from the downloads folder the girls only data set, open it up, and it only contains those variables and those records that we wanted. So it was that easy to subset your data and get it ready for analysis in Rocketfish. Now let's go ahead and do that same kind of work in Excel. So in Excel, we'll go back to our combined clinical data, and what I recommend is that you, at this point, really use the record counter on the left to help you with doing subsetting. So the first thing that we're going to do is we're going to create a copy of this worksheet. And we're going to say create copy right before the working data sets. And we'll go ahead and move this over here. And we're going to rename this, and we're going to call this boys only. And the way we're going to do that is we're going to take our data and we'll put on filters. We'll then be able to filter based upon having any of the girls in our data set. And you can then select these variables and hit delete. And so now if we unfilter our data, we have only the boys. It was that easy. Now, let's say we wanted to now bring that data set into a new working data set, but we only wanted to include the variables that matter to us. So one way we can do that is we'll go ahead and we'll put this right in front of the boys only, create a copy. And so now we have a new boys only data set, and you can go ahead and just select which of the variables you want to keep. And here we can say, okay, we're only going to keep the gender, and so we'll go ahead and move this over here, and we're only going to keep the HIV positivity, we'll put that here, and the BMI, we'll put that over here. So you may say, oh, what are you doing? Well, don't worry, I'm going to show you a trick. So we're just going to go ahead and delete all of this data. We don't even need the student anymore, so we can go ahead and get rid of that as well. And so we're going to bring over just the data set that matches these variables, and the way we're going to do that is we're going to use a VLOOKUP formula. So we're VLOOKUP on the record counter, and we'll say, okay, based upon the record counter, give me the data from our boys only data set. We'll go ahead and lock that in place. And then we're going to do a match function again. We'll come back and we're going to say, based upon matching the gender variable, based upon matching the variable name, in this case gender for the first, we'll lock in that first top row, and then we'll come over here and we'll say, look at the entire list of variables from left to right and give me an exact match. So now what I've just done is I've used the record counter as my key between these two data sets, and as a result I should be able to bring in all the values even though I don't have the unique identifier for this data set. And that's because I'm using the record counter, which is really fast and easy to use. So here we've just done some dimension reduction and we've done some record subsetting using Excel. Okay, now that we're done with talking about all of our data prep steps, we can go ahead and finish up with a little conversation about analysis and data sharing. So in terms of data analysis, there are two different types of analysis that we tend to see. The first is a statistical analysis, where the goal is to produce a numerical model of a sample of a population. And so the methods include descriptive statistics, where you're modeling the actual sample that you have measured, and you're looking at the tendency and the spread of that population. And you have different measures there. Median and mean are both tendency measures. Spread can be variance, standard deviation. And so with these statistics, we can understand the shape. When it comes to inferential statistics, we are talking about the ability to explain relationships between the variables. And the most common one is ANOVA. So literally, ANOVA means analysis of variance for the groups that you have created. So we could have done an ANOVA analysis based on the cross-section of gender and HIV positivity on BMI. That would have been groups of data that we could test to see what's the impact of gender or HIV positivity on predicting BMI values. And that's just about explaining the variance to know if they're significant or not. When it comes to linear regression, this is where you're trying to create an explanatory model, one that can tell you what's the impact of each variable on another. So you may want to say, what is the impact of HIV positivity and gender on BMI, and you'll be testing to see how much does gender add to the BMI and how much does HIV positivity add to the BMI. And that kind of linear regression is very explanatory. It's easy to interpret. And then finally, logistic regression is all about compressing your data set to get power in predictions. And so it's not as easy to explain what's going on with the data, but it is very easy to predict what will happen. So that's all the numerical modeling. From a modeling and simulation standpoint, what we're trying to do is support decisions. And so modeling and simulation is a little bit different. You definitely still use models like what you develop in statistical analysis, but you're using them for the purposes of supporting a decision. And so a first method would be a conditional model. And in this case, we're talking about looking at, based on inputs, what are the outputs you could expect. And a good example of this is when you talk about Go terms, in terms of looking at, based on the expression of, based on inputs, what are the outputs that you expect in terms of a phenotypic response from an activated gene. When it comes to deterministic models, we're talking about cause and effect. So this is where you literally have modeled out the chain reaction that you anticipate based on physical laws. And a good example of this is ingenuity pathway analysis, where you literally are modeling how each one of the interactions within the body will affect the other based on activation of genes. With machine learning, you've developed algorithms which are able to learn as they go. So they may be employing a number of deterministic conditions or decision trees, and then continue to add conditions and add probabilities based upon the results they get from reading data in terms of inputs and outputs. And then finally, simulation. And simulation is where you already have a model, and maybe one of the three that came before this. But in simulation, you vary the inputs to understand the variance of the output that you would predict. And the most common example of this is your 3-day forecast, where you have the highs and the lows based upon all the variance of inputs and the variance of outputs you would expect with the weather, because who can predict that? So modeling and simulation is a great way to support decisions. Statistical analysis is a great way of explaining relationships. And that's kind of the two types of analysis we tend to see. Now, in both cases, the answers from this analysis can be worked back into your data prep workflow like we talked about, and especially when it comes to extraction with dimension reduction or integrating results in order to classify your variables and do more cleaning and transformation. So hopefully that's a good high-level overview for you in terms of data analysis. Next, we're going to talk about data sharing, and this is essential for all the work we've talked about in this last hour and a half of course education. Data sharing really comes in two forms. You have peer-to-peer, where you're collaborating with someone and you're sharing data in order to do work together. And you have dissemination, where the goal is to contribute to the field of study by putting your information out there. So with collaboration, we tend to see three main types of collaboration methods. First is a secure file transfer protocol. And this is actually something you can get for free from the Army. Armadeck website will provide you with an SFTP that lasts for about 30 days. It's a great tool to use, something that I learned from working in the Navy for a number of years. Also, virtual drives are great, so Google Drive or Dropbox is wonderful. Just know that Dropbox is not always secure and is a lot less secure than most people know. In fact, it's very easy to hack Dropbox, so be careful about putting your files on virtual drives if you don't know the security standards there. Finally, external hard drives are wonderful for large amounts of data. The fastest way to ship terabytes of data is to literally put that data in a drive and then ship it on wheels. Going over the internet is way too slow. Amazon Web Services and the Amazon Cloud still has shipping services for really large data sets, and I can tell you that from experience from working at the National Archives. Now, when it comes to dissemination, there are many ways of disseminating, and it's not always through publication, although that's normally what we think about. Publication is the most natural way of doing it, where you provide your findings to a journal and a great paper that explains them, and always a conclusion that has the future that you predict. But then online repositories are another great place to put your data so that it can be used and offer a chance for collaboration in the future. So those may be managed by the journals themselves. Nature has a great repository, so does NIH, as well as many nonprofits. And then something that isn't used as often as it should be is an institute website. So a great example of this is the Lieber Institute, and they have more brain samples than anyone else in the world. And what they do is they provide all of their data and the canonical data analysis online so that you can then go through and process that data yourself. And so it's a great opportunity for them to collaborate and to provide information that the world can use to study the brain. And lastly, specialist data centers. These are the ones that are oftentimes based around communities of practice. So a great example is OpenStreetMaps, and that's because those data centers are being managed by an open community, and they're being peer reviewed, and it's a great source for integrating data sets that are very similar by type, like geospatial data. So the one thing I want to point out is that when it comes to sharing data, there is a enormous amount of benefit to you as the individual and to the community when you share your data. And in fact, it increases your prestige, it increases your research accuracy, and your perceived trustworthiness. So more people are going to want to work with you. And that's the reason why Simple Data Management is going to help you with a lot faster discoveries, because if your data can be used by other people, that means you're going to be collaborating more, you're going to be producing more, and the reality is that currently, on average, every paper has at least 2 institutes and on average has 8 authors. And that is a testament to the power of working together and why Simple Data Management, we believe, is the future for managing data and research. So we hope you've really enjoyed this presentation, and very much appreciate you taking the time to watch this video and learn a little bit more about the concepts of simple data management. If you have any questions whatsoever, please feel free to email me at john.johnson@secondnaturesoft.com and visit our website, because there you'll find more information about Rocketfish, lots of great examples, use cases, etc. And I promise you, some of them are very fast if you want to just jump through and see exactly what matters to you. Also on February 8th, if you are watching this before that time, in 2017, we're going to have a in-person training at NIH Library, and that's a great opportunity to come in, learn some new skills, and get some one-on-one coaching from me and the Rocketfish team. So thanks a lot, and I hope you have a great day.